This is exam 1, page 10, section 6, and it's question number 2, and it asks, what value must k be assigned so that f of x is continuous at x equals 3? Then we're given this, and we're gonna start by setting them equal to each other. So it's gonna be negative 3x minus k is equal to 2x squared. And then we're gonna move this over so that we can get it equal to 0 and then therefore be able to solve for k. So then we'll get, we're gonna subtract 2x minus 2x squared on both sides. So we're gonna get negative 2x squared minus 3x minus k, and that will be equal to 0. And then after that, we're gonna plug in, now that we have this f of x, oops. Now we're gonna plug in, this should be, actually, sorry, this will be h of x. So we're gonna we have to make sure we put let h of x equal this equation. And then since we have that, we want it to be continuous at x equals 3, we're gonna do h of 3, it's gonna be negative 2, 3 squared minus 3 minus k, and then it's still going to be set equal to 0, so then from there we're going to solve, and this will be 9, 18 minus 9 minus k, so then this is going to equal negative 27 minus k. Oops. Minus k, still equal to 0, so we're going to add k to get it alone, and then we get that k equals negative 27. So we found our k value. Let me get a different marker. We found our k value. So now we're going to replace this value into this equation for k. So we're going to get let f of x equal, and we're going to put the same thing except it's going to be a tad bit different. We'll do negative 3x plus 27, because it is negative 27, but there's a minus here. And then it's going to be the same thing if x is greater than 3, and then this will stay the same at x is 2x squared, and then that's going to be if x is less than or equal to 3. Now we want to find the limits from the left and the right, get the answers, and then from there we can see if we can prove that this will be continuous at x equals 3, if they're equal to each other. So we're going to do the limit of f of x as x approaches, we're going to put 3 from the right first. You can kind of do either way. And that's going to be equal to, and because it's from the right, if it's coming from the right, it's going to be greater than 3. Because if you have 3 here, it's going to be greater. It's going to have to be a greater value if it's coming from the right. So we'll use this equation here, and reverse what I said. That was what I was saying for approaching from the left. As you approach from the left, x should be greater than 3, therefore you're going to use this equation for approaching from the left. And then it's 3 plug in this value here, and you're gonna get, -3 squared. It's gonna be -9, because 3 times 3 is 9, and there's one negative, and then it's gonna be plus 27, and you're gonna get 18. Now, what I was saying, for the limit of f of x as x approaches from the right, sorry about my miscommunication earlier, you're gonna use this equation. So, here you're gonna plug in the same thing, x squared, because if, what I meant to say is, if it's approaching from the right, it's gonna be, x is gonna have to be less than 3, so then you're just gonna plug in 3, so 2 times 3 is, no, 3 squared is 9, so 2 times 9 is also gonna be 18. So these two limits are equal, and then therefore we're gonna still have to find f of 3 and just show that they are equal. So f of 3 is equal to, it's gonna be the limit from the left and the right. So we can just put, you know, the equations, you can put 18. We'll do 2, it'll be 2, it's gonna be 18, because that's gonna be the one from the left, and then it's also, that's gonna also be equal to 18, because, as I said earlier, so the final answer should be 18, and it will be continuous at x equals 3, because we get the same value for both. That's it.